Welcome to the University of Strathclyde USEV team and the University of Aberdeen ProtoTAU team presentation of our joint project, Protosev, our vision and design for a car for the year 2040.
In this first section, we will discuss the more mechanical aspects of the vehicle. Starting with the suspension, the shock absorbers in the mechanical suspension will be replaced with the regenerative shock absorbers to convert the energy of the vibrations, which is usually wasted as heat, into useful electrical energy. For average-sized vehicles, an electromagnetic system would be used and would consist mainly of a stack of permanent magnets moving through coils to generate electricity. The electrical load of producing this energy, providing the physical resistance to vibrations, similar in concept of how regenerative braking slows down a vehicle. For larger vehicles, they will likely require a stronger design that instead uses hydraulic pistons to force fluid through a turbine to generate electricity. This design can handle the higher loads demanded by larger vehicles and would be useful for larger vehicles used in transport infrastructure. It's claimed that you can recover between 20 to 70% of energy that would be lost in a traditional suspension using these systems, increasing the total average range of the vehicle.
Now onto the internal of the vehicle. We're going to use a more eco-friendly polymer this time. We're going for a bamboo reinforced polymer. This will allow it to be recycled a little bit easier, especially with a standard or unidirectional weave, allowing the recyclability to be more effective. So now on to the structure of the vehicle. We're going to use a monocoque chassis, which is known as a structural skin that supports all of the loads. This is compared to an eggshell to give you a good example. The material that will be used will be carbon fiber reinforced polymer, and they'll have three main types of weaves. A plus or minus 45-degree biaxial, which will be on the structural members running the length of the car. This will increase the torsional stiffness. We'll have a unidirectional cross-woven tape that will go around the bulkhead to increase the hoop stress, and any other section will have a 0-90-degree weave.
In this section, we're going to be discussing the electrical aspects of the concept vehicle that we've been designing. Firstly, on the power sources side, there are going to be two power sources in the vehicle. Firstly, a small battery, which is positioned under the driver's seat, which will be used for start-stop driving in cities and towns. This is also supported by a hydrogen fuel cell, which can be used for longer range driving. The battery technology that we're going to be using is a technology called cobalt-free lithium-ion batteries. These are something that is gaining popularity these days as it removes cobalt from the battery, which is not only costly to mine, but it's also very costly and has environmental consequences when processing it. So hopefully this will not only be a cheaper source, but it'll also be more environmentally friendly. For charging the battery, we're going to be using two sources. Firstly, you can charge it directly through a connector, as you would use for many other electric cars and plug-in hybrid electric vehicles these days. And secondly, we are looking at a technology called inductive charging. And this is very similar to what is used in wireless charging in smartphones, except it's scaled up to a much larger size. You have a charging coil in the car and multiple charging coils in the road. This is currently under investigation in cities around the world, and hopefully it will be a technology that will gain a lot of popularity in the future because it allows you to essentially keep your battery charged without having to plug it in. I'm now going to pass you over to Ross, who's going to be discussing the actual drivetrain of the vehicle.
The vehicle will use 4 hub-centric motors that can be controlled independently. This is the benefit of being able to implement them in complex algorithms to improve vehicle dynamics while cornering, but also be able to turn individual motors off to improve efficiency for long journeys. The motors will also be able to be used for regenerative braking. This allows the motors to act as generators and charge the supercapacitor array. This supercapacitor array can then either be used to drive the motors again or recharge the battery. The battery is placed in a position near the centre of the car for increased vehicle handling. The car will be fully autonomous but allow selectable levels of autonomy depending on driver choice. from non-autonomy to full autonomy that consists of the car steering, braking and accelerating for the driver. It will achieve this by having multiple cameras and radar sensors around the vehicle, and these will work in combination with the 4-hub-centric motors.
In cases where the driver wishes to drive themselves, a transparent display covering the front windscreen provides an augmented reality view of the road, highlighting hazards, road signs, and navigation information, and putting all the information the driver requires exactly where they need it. The driver can also use their phone or smartwatch to unlock and start the car, removing the need for keys.
This is the setup of the fuel cell and safety system in the car. The main components are the motors that power the wheels, a hydrogen tank that supplies the fuel cell stack with hydrogen for the electrochemical reaction, a hydrogen protector for the fuel cell safety system, power control unit that distributes the electricity, fuel cell stack that consists of 400 fuel cells, and a battery to store the electricity. So oxygen is drawn in from the atmosphere through the front car grille for the electrochemical reaction with hydrogen in the fuel cell stack. This generates electricity to be sent to the power control unit. The power control unit can do several things with this energy. It can be sent to the battery for storage, to be used later, or it can be sent directly to the motors to power the wheels. The car can utilise regenerative braking, so if the car slows down, the energy from the motors can be sent to the power control unit to be sent to the battery. The water produced from the electrochemical reaction is released into the atmosphere through the exhaust. The hydrogen protector consists of sensors that can detect a hydrogen leak, which are then connected to transmitters that send a signal to control valves to stop the flow of hydrogen to the fuel cell stack.
I hope you enjoyed our presentation. Thank you.